Hello friends, welcome to the video lecture series of probability. In this video, we are going to discuss Poisson distribution. In previous video, we discussed binomial distribution. This Poisson distribution is what? Poisson distribution is a limiting case of the binomial distribution. Normally, if the small n and p, n number of events and number of trials you can say, and p, small p probability of success, if p is very small and n is very large, in that case the Poisson distribution is preferred, means Poisson distribution gives us the better result. So without wasting time, we are going to solve one or two problems on Poisson distribution. So what is the Poisson distribution formula first? Poisson distribution formula is what? P is equal to probability for the success of x equals r. R is a random variable. E to the power minus m, m to the power r by factorial r. And m is what? M is a mean. And mean is n into p. Mean is what? N into p. Small p is the probability of success of each event and n is number of trials. Here, the problem I am going to read very quickly. A factory manufactures razor blades. The probability of being defective blade is 1 by 500. What is the probability that the blade is defective? It is 1 by 500. Okay, this data is this data is coming from the past experience. Razor blades are supplied in a packet of 10 units. Razor blades are supplied in a packet of 10 units. In each packet, 10 blades are there. Find the approximate number of packets containing no defective. Each packet containing 10 razor blades. What we have to find? We have to find the approximate number of packets containing no defectives and 2 defective blades. Okay, these two questions are asked. We have to find out the probability that we have to find out the approximate number of packets containing no defective. That is the first question. And second question is find the approximate number of packets containing 2 defective blades in a consignment of 10,000 packets. In each packet there are 10 blades. And what is the volume of consignment? The consignment containing 10,000 packets. In each packet 10 blades. In a single consignment 10,000 packets. Now here the probability of defective blade is 1 by 500, that is given to you. Probability of defective blade is 1 by 500, that is small p, and 1 by 500 is 0.002. And here in each packet, we are dealing with a packet, in each packet there are 10 blades. So n is what? N is equal to 10. The n 10 multiplied by p means n multiplied by p is what? 0.02. This is mean m we have obtained. Yes, what is meaning of m? In average, mean is 0.02. On an average, there are 0.02 blades. In an average, there are 0.02 blades in a packet, packet containing 10 blades. You please remember. Now, the probability that the packet containing no defective razor blades means packet containing no defective razor blades means what? Probability that r equal to 0. It contains no defectives means 0 defective. So put r equal to 0. M is 0.02. R is what? 0. In this way, e to the power minus 0.02 is what? The probability that, what is e to the power minus 0.02? This is the probability that in a packet there are no defective blades. There are no defective blades. But the number of packets in the consignment of 10,000, we have to find out the number of packets in which defective blade is not there. 0 defective blades are there. The approximate number of packets having no defective blades is what? This multiplied by 10,000, because this probability we have calculated for the single packet. Okay, in each packet there are, what is the probability that there is 0 defective blades in the packet? It is e to the power minus 0.02, and this multiplied by 10,000 means what? 9802 is approximate number we want. The 9802 is what? 980, there are 9802 packets in a consignment of 10,000 containing no defective blades. Second question, we want the number of packets containing exactly 2 defective blades. Here we discuss about 0 defective blades. Now 2 defective blades. Simply put R equal to 2. Here R equal to 2, M is known to you, 0.02. Only 2 things are required here, M and R, that's all. And M, R we get from the question, and M we get from N into P, that's all. The approximate number of packets containing 2 defective blades is equal to what? This much multiplied by 10,000, and it is coming to be 2. And what is P of R equal to 2? What is meaning of this? This is the probability that in a packet there are exactly 2 defective blades. Okay. In this way we have solved this problem very quickly. Same problem again. A probability that an individual suffers a bad reaction from a particular vaccine is 0.01. Find the probability that out of 2000 individuals, there are 3 questions now, exactly 3. Second question, more than 2. Third, none of them suffer the bad reaction. None of them means 0 individual suffers. None of them means 0 individual suffers a bad reaction. Here, the probability that individual suffers a bad reaction is 0.01. That is given to you. This is small p. And what is n? N is 2000, because we have to find out the probability that out of 2000 individuals, n is what? 2000. The m mean is equal to n into p. N is 2000, p is 0.01, and m is what? Mean is 2. Use this formula. This formula I am applying. We want exactly 3 individuals suffers bad reaction. Exactly 3 individuals suffers bad reaction. Put R equal to 3. M is common, M is known to you. And in this way, e to the power minus 2 multiplied by 4 by 3 is the probability that exactly 3 individuals suffers bad reaction. And you can use the calculator and you can get the value of e to the power minus 2 and you can go ahead. Next question is what? More than 2 individuals suffers bad reaction. How many individuals are there? Okay, vaccination is done for 2000 individuals, and we want the probability that, what we want? We want the probability that more than 2 individuals suffers bad reaction. Okay, more than 2 individuals suffers bad reaction. It may be the possibility that all 2000 may suffer from the bad reaction. Now, here the probability that more than 2 individuals suffers a bad reaction. R is a random variable, and random variable is associated with what? Number of individuals suffers bad reaction. R is what? It associated with the number of individuals suffers a bad reaction. The R greater than 2. What we want? We want probability that more than 2 individuals suffers bad reaction. More than 2 means R greater than 2. Greater than 2 means 3, 4, 5, 6 up to 2000. Probability that 3 individuals suffers bad reaction, or probability that 4 individuals suffers bad reaction, plus probability that 5 individuals suffers bad reaction, plus probability that 6 individuals suffers bad reaction, and in this way up to probability that 2000 all the individuals, means 2000 individuals suffers a bad reaction. Okay, means how many probabilities we have to find? The many probabilities we have to find here. Okay, P3, P4, and all these events are mutually exclusive events. Therefore, addition law of probability we are using. Probability that R greater than 2 means what? Probability that more than 2 individuals suffers bad reaction means probability that 3 individuals suffers bad reaction, or probability that 4 individuals suffers bad reaction, or the probability that 5 individuals suffers bad reaction, and so on up to probability that 2000 individuals suffers bad reaction. And here many probabilities we are going to, okay, it is not feasible to find out this much probabilities. In this type of in this situation, we can use the complementary law of probability also. Means total probability is 1 and 1 minus the complement of this. Complement of this means the probabilities which are absent here. Probability 2 is absent, probability 1 is absent, probability of 0 is absent. P of 0 means what? P of 0, probability that no individual suffers bad reaction. P of 1 is what? Probability that single individual suffers bad reaction. P2 is what? Probability that 2 individuals suffers bad reaction, in this way. Now P2, just put R equal to 2, P1 put R equal to 1, P0 put R equal to 0, okay, and P2 okay, P2 is P3 we have evaluated, okay, then evaluate it, okay, use any calculator and get the value. The probability that R greater than 2 is 0.323. What is meaning of this? Probability for R greater than 2 means what? Probability that P of R greater than 2 means what? Probability that more than 2 individuals suffers a bad reaction. Okay, this is coming to be 0.323. Now third question, none of them suffers bad reaction. None of them suffers bad reaction means what? Out of 2000, nobody is going to suffer the bad reaction. Means 0 individual suffers bad reaction. Means P of 0. Okay, substitute R equal to 0 here. M is known to you, 2. And it is 0.135. And value of P0 you can get from here also, because here the P0 is required. The 0.135 is the probability that no individual suffer bad reaction. Means 0 individual suffers bad reaction. Like very quickly, one more problem, because this type of problem are normally asked in UPSC, MPSC, MHT-CET examination. In Poission distribution, if this Poission distribution equation is given, find P of R equal to 3. P of R equal to 3 we have to find. P of R equal to 1 is equal to 2 times P of R equal to 2. P of R equal to means 1 means what? Probability that R is equal to 1 is equal to 2 times probability that R equal to 2. Then put R equal to 1 in this formula. M is not known to you. Okay. M is equal to and R equal to 1. See, R equal to 2 here. This 2 is multiplicative constant as it is. E to the power m is never to be negative, therefore we can cancel in this way. This 2 you can cancel. M square equal to m, and m is equal to 1. M is equal to 1. If there are two values of m is equal to 0 and m equal to 1. The mean here in probability, in practical sense, mean is never to be 0. Then P of R equal to 3. Once you get value of m, this equation has given the value of m on simplification, and m is equal to 1 and R is equal to, probability for R equal to 3 I have to find. So here R is equal to 3, m is equal to 1, and it is 1 by 6 into e. E to the power minus 1 by 6 means 1 by 6 into e. Okay, just very quickly, just one more problem we are going to discuss, because in order to save time, this thing I have written on the paper. Just very quickly now, the next one. In Poisson distribution, this type of problem already we have discussed. Okay, we have already discussed. Very quickly we are going to solve it. Okay, this is Poisson distribution formula. If the probability of defective screw is 0.01. Okay, probability of defective screw is what? 0.01. From the past experience, this data is available. What is the probability that in a lot of 100 screws, there are the various lots of 100 screws. In the lot of 100 screws will contain more than two defective that we are going to find. More than two. Here n is what? N is 100, because in a single lot 100 screws are there, and m is equal to what? N into p. M is a mean. It is 100 multiplied by p, 0.01, and it is coming to be 1. Mean is 1. Okay. Now this Poisson distribution formula, P of r is equal to e to the power minus m to the power r by factorial r. Okay, this equals e to the power m is 1, and what we have to find here, see, m is 1 and r is there. I am writing like this. Okay, I am writing like this. It's 1 to the power r is what? 1 to the power r is what? It is 1, and r is an integer. Okay, here r is a positive integer. Is it? Now e to the power minus 1 by factorial r. The p of r is known to you. What we have to find? We have to find the probability that what is the question? What is the probability that in a lot of 100 screws will contain more than two defectives? Its probability we have to find. What is the probability that in a lot of 100 screws will contain more than two defectives? It's more than two defective means what? P is r greater than 2. Okay, r is what? R is a random variable and which is associated with number of defective screws, and this can be written as 1 minus probability that r is equal to is p of r greater than 2 means what? P of 3 plus p of 4 plus p of 5 up to p of 100. Okay, in previous problem we have done this type of thing. Then p of 0, p of 1 and p of 2. Okay, here directly I am writing. Now p0, p1, p2 you can find out r greater than 2. Here 1 minus p0. P0 is what? E to the power minus 1. P0 put r equal to 0. P1 put r equal to 1. P2 put r equal to 2. Okay, the 1 minus e to the power minus 1, and this is factorial 0 is 1, factorial 1 is 1, and it is 1 by 2, and what is this now? 1 minus e to the power minus 1, and this is 5 by 2, 2 plus half is 5 by 2. Okay, and if you use the calculator, and this value is just written here 0.0803. Okay, this is the probability that in a lot of 100 screws more than two defective screws will be there. Okay, and we have to find out the probability. If you want the number of screws, then you can multiply it by 100, but it is not asked here. Okay, it is not asked here. And here in all those problems, P, probability of success for each event is very less. This one. Okay, in previous problem it was 0.02 or like that. And n was very large. 100, 200, 2000, 10,000 like this. Okay. Here the Poisson distribution is convenient. Okay, it gives us the better result. Okay, if you solve this problem, okay, if you solve this problem by binomial distribution, okay, if you solve this problem by binomial distribution, what see, in short I am going to write the P of r greater than 2 is what 1 minus P of 0, P of 1 and P of 2. Okay, P0 is probability that 0 defective screws in a lot of 100. P of 1 defective screw in a lot of 100. P2, probability that exactly 2 defective screws in a lot of 100. Okay, and if you use this binomial distribution formula is what? What is the binomial distribution formula? Is NCR and combination with R. P to the power r by this multiplied by q to the power n minus, like this. Okay, and if you use this one, then here n is 100, C, r is 1, P is what? P is 0.01. Okay, to the power 1, here 0, you know. P of 0 I am finding, and 0.99. Okay. P is here, P is 0.01. Therefore Q is what? 1 minus P. Probability of success and probability of failure. Q is probability of failure. In that way, the 1 minus 0.01 means it is 0.99. Is it? P is the probability that the screw is defective, and Q is what? Probability that screw is not defective in this way. Plus P of 1 is 100 C1 0.01 to the power 1 0.99 to the power what? 100 minus 1 is 99, is it? Plus P of 2 100 C2 0.01 to the power 2 and 0.99 to the power 98. Okay, directly written here 90, because this we have already discussed in binomial distribution. And if you calculate it, okay, because I have calculated here, if you calculate it, the 0.0794. Okay, the same problem, if you solve it by binomial distribution, so this is the probability. Okay, means it is Poisson distribution is more powerful than that of the binomial distribution when n is large and small p probability of success of each event is very small. So, hope you understood this. We stop here. Thank you very much.